All right. A warm evening again. So here we have a chemistry paper, right? And then we're looking at organic chemistry. And if you can remember, organic chemistry constitutes of a lot of marks in your paper 2 chemistry final exam. So let's make sure that organic chemistry we get all the marks, right? The series will go as follows. As we are looking at organic chemistry, we shall have some time whereby we have some mini course nights on this topic alone, and rates of reaction, including chemical equilibrium. Yeah, but otherwise here we are given that we have some different compounds that are represented, right? And then the first question asks us to say which letter, write down the letter that represents a ketone. Which one is it, guys? Yes, Miss Yolanda.
It's B.
B. A ketone. Let's check B. B. Oh yes. What sparked your response, ma'am, if I may ask? Like, what made you think that one is a ketone? Yes.
Sorry. It is the position of the structural functional group, actually, sorry. Basically, the oxygen being in the second position to third, being in the middle.
Functional group, okay.
Yes. If it was aldehyde, then it would have been on the first, which is its isomer.
You know what I like, ma'am? You are saying it would have been on the first, the oxygen. What actually is the name of the functional group for ketones?
For ketone, isn't it carbonyl? I think it's carbonyl or carboxyl.
Carbonyl.
No.
Yeah, that's
it
correct.
It is carbonyl.
Yes, it is carbonyl. Actually, carbonyl is this part. Is oxygen bonded to carbon, okay? We call this carbonyl group. We call it a carbonyl group. Now, if it happens that this carbonyl group is bonded to other carbon atoms, 2 other carbon atoms, then we usually call it a carbonyl group. But then if that carbonyl group was bonded to a hydrogen, right, then that would be called a formyl group. And we would call this an aldehyde because this is the functional group for aldehydes. Great stuff. So yes, indeed, this is the answer here indeed is B, right? Thank you so much for that. Very nice. And then 2.1.2 says which one is a structural formula, right? Number 1. You know, when you read these questions, always take note what they're asking for. They're asking for a structural formula. Before you go any further with the question, remember what is a structural formula. Because remember, you have 3 formulae, right? You have the structural formula. Which one is the structural formula, or what is the structural formula? Right, remember it shows the carbon atoms, like it shows the atoms and which other atoms they are bonded to. Like if you have a carbon and it's bonded to a hydrogen, right? A structural formula is a structure, meaning is a visual structure of that compound, right? It will show you the visual structure. So if they say structural formula, just remember that you must draw structural formula functional group of, it means you must draw. I always say this because in most cases these questions, they seem simple, but then the wording takes us out. Someone might just write the formula, or someone might write the condensed structural formula when they need actually the complete structural formula. So structural formula, we need the structure, we need to draw. we need to draw. Okay, then condensed, it will be, you know, something like this. This would be a what you call a condensed structural formula. So you condensing the structure. Then remember, we also have a molecular formula which shows the type of element and the correct number of atoms that are bonded in a compound. But then in this case, we want the structural formula for the functional group of C, right? For the functional group of C. So the fact that they wanted a structural formula, we must draw that functional group of C. C is here. Which homologous series does C belong to? Anyone who can tell us which homologous series does C belong to? Yes, so C belongs to, I always say this, right? For you to know, especially when you're given a condensed structural formula, just check out for the following type of words, right? If you have things like COOH on the condensed structural formula, then you must know that you are referring to a carboxylic acid. And then if you have things like is it something like this? Or maybe it should be something like this. If you see maybe something that will be looking like this, that is probably in ester there. And then CHO, that will probably be a what? An aldehyde. These are some of the giveaways that they give us in the questions. Try to check out for those. But I think I do also have like a full chemistry reading video where I go through most of them. Try to check them out. Okay, but then here, this would be your what? It should be your aldehyde because it is CHO. So they don't want the name of that. They only want the structural formula of the functional group. So it means for 2.1.2, we should have drawn C, the carbonyl group bonded to the hydrogen. So that is how you are supposed to have, oh, it's only one there. This is how you are supposed to draw it. Then you would get your 1 mark then. Okay.
Sorry, I can't see it.
You can't see. Yeah. So for compound D, right, which is this one here. Yeah. So for which one? Compound C, right? This is a compound C. Then we wanted it what to call the structural formula of the functional group. So it means it will be this one here. Okay, that will be the one because it's an aldehyde. And then they say write down the general formula of the homologous series to which compound A belongs. Compound A is this one. Which homologous series does compound A belong in? Yes, ma'am.
It belongs to alkenes.
It belongs to alkenes, right?
Yes.
Alkenes. What tells us that?
It is the triple bond that we have there.
The triple
between
bond.
the carbon.
Yes. Beautiful, beautiful. So because of that, we are able to tell which homologous series we're referring to. Great stuff. But then, remember, they wanted the general formula, isn't it?
Yes. Yes.
So what would be the general formula for alkenes?
The general formula would be CnH2n.
CnH2n. Great stuff.
Yes.
Great stuff. Thank you so much. Right. Great. And then now, For 2.1.4, we needed the IUPAC name of compound A. So the very same compound we just identified, now we need the IUPAC name. I don't know if you managed to draw it somewhere because usually you have to draw it to see the longest chain. I can try maybe to also draw it here. It's H, right? You start with H, and then you have a C, and then you have H again. You have a C, and then you have C, H, H, and then another H. And what do we have? C and H, right, like this. And then goes on like that. I hope I didn't miss. So you have H here, let's see, you have C, H, and H, then C, H, H, and H, right? Then you have a triple. You have carbon, then a triple bond, and then C, and another C, and then H, right? Ooh, so which one is our longest chain? Would I be correct to say this is the longest chain here?
No.
Okay. What could be the reason though? I mean, count those carbon atoms, man.
There's 6 carbons, but another chain makes 7 carbons if you start from the CH3 to the
From
so
this
7
side.
has to be the length. Yeah, starting from that side.
Okay. Let's see.
2, right.
Oh, nice.
So that is the longest chain.
That is the longest one. And very important, it must have your functional group. Ne? So now we can name or rather number. So check. When I'm numbering right, if I say 1, 2 here, I already, if I say 1, 2, 3, I meet a substituent here, right? Please do not take this as a substituent. It's still part of the chain. Now, then if I say 1, 2, 3, I then meet the functional group. So where must we number from? Is it from the left to right or right to left?
Right to left.
Right to left, right?
Yeah.
Reason being?
Because we number starting from the side with closest to the functional group.
Closest to the functional group, right? Wait. Maybe let me give you this one, yeah, so that we can maybe see. Let's say you have C, right? Then you have C, and then you have a double bond here, and then you have C, and then you have C, and then C, and then another C, right? Ooh, okay. Then you have CH3 here, and then CH 1, 2, 3, yeah, CH3. And then let's see, you have H 1, 2, 3, 4, 1, 2, 3, and then 4, and then here you have H. Then let me just call this here CH3. Okay, so in this case, from which side should I start numbering? Because I can identify the chain here to say maybe the longest chain is actually this one, right? That is the longest chain. So should I number from this side right to left or left to right. Because if I say here 1, 2, I meet the substituent, right? 1, 2, I meet the substituent. Then if I say from the left, now I can use a white, maybe a green, a red, orange. Okay, 1, 2, and then 3. That's when I'm meeting a double bond. So from which side should we number?
Left to right.
Left to right. Why left to right?
No, I mean the other way around. The way he started with the 1.
Right to left.
Yeah.
Okay. Anyone else maybe who has a different view?
I'm not sure if I'm right, sir, but I didn't really consider the substituents. I thought it was all about where the functional group was positioned, and in this example, it is in position 3 in either sides, whether right to left or left to right. So I would have numbered from left to right because I don't think it would have mattered. Correct me, say.
Okay, I know I'm hearing you. So you're still focusing, but like you're still focusing on the functional group. Can we say you're still focusing on it? Because you're looking at this number and you're like, from left to right, right to left is still on position 3, isn't it?
Yes, sir.
Okay, right. So we have what you call let me write it here. Let me try to write it here. We have what you call the priority list. Ne? We have what you call the priority list. What is the list used for? This is used, right, for numbering. Used for numbering carbon atoms in a chain, right? It's used for numbering carbon atoms in a chain. So in terms of this list, right, it goes as follows, right? It starts with COOH, right, which are the acids, carboxylic acids. It goes to CHO, which are the aldehydes, right, the aldehydes, and then OCC, right, C, which are the ketones, and then I'm hoping you'll be able to see that here. Okay, let me make some small arrows here so that it does not confuse us, ne? Or maybe we can call it number 1, number 2, number 3. Yeah, even better. Number 1, number 2, number 3. Right. So here is your number 1 here. This is your number 2. This is your number 3. There is number 4, 5, and then 6.1 and 6.2. right, that is what we have. So now for number 4, you can never guess. Triple bond. It's the triple bond. And then here we're gonna have the double bond, and then we have X, which represents the halogens, and then we have the alkyl group, ne? The alkyl group. Right, these ones, they serve as the prefix. They usually are part of the prefix and get like they are taken as substituents. That's what we are trying to say. Substituents. They are taken as substituents. So how does this priority list work? If it so happens that in your parent chain, right, you happen to come across, let's just say, something like this. Yeah, try. OH, yeah, and then you have C, and then you have C, right? And then let's just say miraculously you happen to stumble upon the double bond, right? Then this is what we have. Perfect. So I want you to look at this compound here. Look, this is the parent chain. Obviously it's the longest chain of carbon atoms, but where would you number from? I'm asking you again. Where would you number from? 1, 2, or 1, 2? Oh, sorry. Oh, how did I write that? 2. 1, carbon atom number 2, or would you say carbon atom number 1 here, carbon atom number 2 there? From which side are you going to number from? Left to right or right to left?
Right to left.
Right to left. It's like you like your double bonds, ma'am. Triple bond, double bond. No, I see. Well, this is what we use to guide us, okay? So what this means is that if you happen to have a combination of these functional groups, if you have to have a combination, you're going to number from the side from where the one with the highest priority will be. I spoke Chinese. Let me try to speak Zulu. So what I'm saying is that, let's say, for example, in this case, this functional group here belongs to the carboxylic acid, is the carboxyl group, and then this functional group here is a double bond, right? You look at the two functional groups according to the priority list, and then you say which one is at the top, right? The list goes like this, is like from top to bottom, okay? It goes from top to bottom. So it means the alkyl group is the one at the bottom, right? The first one, which is the highest priority, is the carboxylic acids. So when you look at the carboxylic acids and the double bond, the one with more priority is the carboxylic acids. So that is the side from that is from where that is the side from which you start numbering. Yeah. Okay, so it means we actually have to say 1, 2, 3, and then 4. Okay, the double bond has less priority. So that is what we use there. Okay, is it clear? We can try another one.
Yes, sir.
Perfect. We can try another one to see whether we understand. I like this one. So when I have C, right, I have C, and then I happen to have bromine here, and then I have C, and then I have a double bond here, right, and then I have C, H, and then H, and then 1, 2, 3, 4, and then here, and then here, and then here and here. From which side are we going to number from? The right to left or left to right? according to the priority list, right? When you check, the double bond is here. This is the double bond, and then this is a halogen. Okay, it's a halogen, so it falls here on X. So as you can see, the one with higher or more priority is the what? Is the double bond. So when you number, you have to say 1, 2, 3, 4. Okay, right? So that is what we have. That is your priority list. Okay, so in terms of what I asked you just at the bottom here, right? You have the double bond, and then these ones, I get it, these are both kind of, what do we call, methyl, ethyl, propyl, butyl, and the likes. They are called the alkyl group. Okay, they are called the alkyl. They belong into the alkyl group, right? Then here we have a what? Here we have a double bond. So we go to the priority list, and then we check. The alkyl group is at the bottom, the double bond is on top. So that means the double bond takes more priority as compared to the alkyl group. So when we number, we must number from the what? We must number from the left to the right. 1, 2, 3, 4, 5, 6. Okay, so I hope that is clear. That is how we use the priority list. So you always check to say from which side are you going to number your carbon atoms. It depends on the priority list. And don't worry, your examiners, they know very, very well the priority list. So you must make sure that you number correctly. Now, for going back to this, right, what we had, we can see that here we have a triple bond, right? You have a triple bond, of which when you check it in the priority list, it's here. And then you have some substituents, like this is a substituent, this is a substituent. They fall under the alkyl group, and when you check, the alkyl group is at the bottom. So that means when I number, I must number from the side where I'm going to meet the triple bond first. Okay, so you would number it in this fashion. Okay, so that is how we would number that, and then from there, that will enable us to name the compound, isn't it? So when we have to then name the compound, we can call it, we can say, usually remember, these are the substituents, they are regarded as the prefix. So we start with them and say, this one here is it's a methyl, right? It's a methyl because it has one carbon atom. This one here is in what? Is an ethyl because it has two carbon atoms. Would it be correct for me to write this 5-methyl and then I say 4-ethyl, and then in the carbon atoms, in the chain there are 7, so that will be hept, and then the triple bond is in the third one, so hept 3 in wine. Remember, that is a triple bond. Will this be correct? What are your thoughts, Ms. Samke? Is this coming okay? Is this correct? Where do you see the errors?
The first error, it is in hept 3 in. It's supposed to be hept 3 Y and E, because E and E is for double bonds, which is alkene.
Oh, so here I should have Y and E, ne?
Yes.
Okay.
And okay, this second one is more of a question.
Yeah, it's a question. Yeah.
Aren't we supposed to label according to alphabets? If you're doing it that way, then the ethyl must have came before the methyl.
Yeah, that's very, very true. So yes, we can't have a methyl before ethyl because we do name according to alphabetical order, right? So it should be what? 4 ethyl, ne?
It should be 4 ethyl, 5 methyl, have 3 YN.
Let me write. 5 methyl. Is there something wrong?
A. You said di, sir. And di indicates that we have 2 ethyl groups, but we only have 1 ethyl group.
Oh, I thought di indicated the number of carbon atoms.
It indicated the ethyl group.
The ether. Okay, that's good. Trust me, these are mistakes that people do out there. Right, then you say 4 ethyl and then 5 methyl hept. So it's now correct. Good, all good. Raise your hand if you say this is correct.
It's correct, sir.
Correct.
Yes.
I want you to check here, right? And then look at the diagram. Is that really, really correct?
Can you repeat your question, sir?
On these 3, you seeing these 3 here, right? Yeah. I want you to look at the name, look at that 3, and then look at the diagram of the structural formula, and then tell me whether it's really, really correct that we put 3 there.
Wouldn't it be 2?
Yeah, it would be 2.
It should be 2, right? Yes, it should be 2, because remember, we take the lowest number, isn't it?
Yes, sir.
Perfect. Perfect. So yes, indeed, it's 2 there, right? So you see, these are the errors that I'm trying to say as we go and write our final exam. Let's always be cautious, especially when you have to name the compound, right? Always double check and then see if you followed all the right procedures, right? That was 1.4, and how they mark it, they mark you for the if everything is correct there, it's given a mark. Then what do we have? We then have 2.1.5, which is asking about the IUPAC name of compound B. This one, what would be the name of that one? Compound B.
I don't know how to say it, but can I spell it?
Yes, it's fine.
It would be BU
BU
TA
TA
then NOE.
NOE.
No, no, it's E.
Like this.
Yeah.
Okay. It looks very, very interesting.
Please wait. They supposed to be an A. They supposed to be an O after the A. So it's gonna be BUTAO. ONOE.
Oh, like this.
Yeah, that. Yeah, something like that. It's fine. It works.
It works. Right. Okay, that is very much correct. We look at the number of carbon atoms. It is indeed 4, right? So it means it will be bute. But now this is a ketone, right? So usually for ketone, for aldehydes, right? For alcohols, for esters, in fact everything except the hydrocarbons. If you can remember your hydrocarbons, right? Your hydrocarbons are which one? Hydrocarbons is the alkane, and alkyne. Okay, and alkyne. And these are hydrocarbons because they only have hydrogen and carbon. So now for all others, usually when you name, once you have identified the number of carbon atoms in the chain, you put AN. So if it was prop, you say propan, butan, ne? Then you say since it's a ketone, then the ketone, the suffix will be 1, so it will be butanon. This is because things like alcohol, you will have to also say, if it is 2, right? Let's say you have C, and then H, and then OH here, and then H. This is an alcohol, right? You would start by saying, since there are 2, it's eth, but then you put AN to say ethan, and then you say the suffix for alcohol is all, right? So the suffix is very important. So this will be ethanol, and then you can have butanol and the likes and the likes. So this one will be butanon. Pronunciation might be a problem, but then here, as long as we get it correct, that should be fine. And then 2.2 says the compound D is a gas, right? Butane is a gas that is used in cigarette lighters. If you can remember that cigarette lighter, it looks like something like this, and then it has a nice wheel here, right? A nice wheel here that people, when they turn the wheel, it usually sparks here, or produces a flame. So inside there we are told that they are using what? They're using a cigarette lighter. They're using butane. So yeah, to which homologous series does compound D belong? Butane. Which homologous series? Are we 2.2.1? Yes, ma'am.
It's alkane.
Alkane, right? Perfect. That will be an alkane. Right, then there is a number 2. Write down the structural formula, right, and the IUPAC name of a structural isomer of compound D. Of the structural isomer, right, of compound D. If you can remember, in terms of isomers, ne, we have structural isomers. What are structural isomers? Remember that these are organic compounds with the same molecular formula but different structural formula, right? I want you to analyze that statement. Organic compounds, right, with the same molecular formula, right, same molecular formula but different structural formula. Those are your structural isomers. Structural isomers, the molecular formula will be the same, meaning if I'm talking about C and H, you'd find that both of them is C3H6, both of them. However, they have a different structural formula. What does having a different structural formula mean? Let's remember that a structural formula is the structure of the compound. So we need to draw the structure. So it tells you that yes, they are going to have the same molecular formula, but the structure is going to be different. The way we draw them is not going to be the same. So the way we draw them could not be the same. In which way? In three ways. Okay? In three ways. It's either that right. It's either when you draw the other one, the position of the functional group is not in the same position as the other one, or the position of the substituents are not the same. So that one would be that type of structural isomer would be a positional isomer. Here they will have different position of what? Of functional group. Or it could be that the other one, when you draw it, right, the chain length is different. So then we would call it a chain isomer, right? So this one would be saying different types of what? Different types of chains, right? Or it could be that when you draw it, it just so happens that the functional groups are not the same, which means that that one would be a functional what? Isomer. Okay, so this one will have what? Different functional groups. Okay, so we have three types of structural isomers. We have positional isomers, we have chain isomers, and functional isomers. Structural isomer is an umbrella term, like it's a term that is in housing all of the different isomers that we have. It just says that they have the same molecular formula, but they have different structural formula, which means they are drawn differently. You understand me? They are drawn differently. Now, how are they drawn differently? You might find that the position of the functional group is not the same. Then we give them a specific name to call them what? Positional isomers. Or you might find that when you draw them, they have different types of chains. The other one has a longer chain length, this one has a shorter chain length, but they have the same molecular formula. Then we would call them chain isomers, right? And then you might find that the other one, when you draw it, the functional group of it is not the same as the functional group as the other one. Then that tells you that those ones are functional isomers. Okay. So when they are asking you to write down the structural formula, is to draw, they use the word write to make you forget that you have to draw. So you must always take notes there. That's why I'm saying take note of the wording. And then they want also the IUPAC name of the what? Of the structural isomer of compound D, which is an alkane. Now you must understand that alkanes, they don't have functional isomers. There's no way you will say I drew two different alkanes with the same molecular formula and the other one became an alkene and the other one became an alkyne. There's no way. So alkanes, they don't have a functional isomer. What has a functional isomer though? It's what? Ketones and aldehydes. Okay, ketones and aldehydes, they can be functional isomers, because you might find that this ketone here, if I move this OH, right? Oh, sorry. If I move this OH to the end, keeping the number of carbon atoms still the same, right? If I make it like this, that O and C, I move it at the end, and then I still keep the 4 carbon atoms like this. 1, 2, 3, 4. 1, 2, 3, 4. I have just moved the functional group, right? But the molecular formula of this will be C, how many? C3, and then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, C8O. Same thing will be for this one, right? If you were to draw, or rather write the molecular formula of this, right, if you were to write the molecular formula of this one here, you'll find that it's also C3H8O. However, they are now two different compounds in a sense that they belong to different homologous series. The other one is a ketone, the other one is an aldehyde, right? So that means those ones those ones will be functional isomers. They will have the same molecular formula but different functional groups. Okay, and then alkanes will most probably fall under chain isomers only. They don't fall under positional isomer. They do not have positional isomers, because on an alkane you can't say, let me show you. You can't say this is an alkane, right? Then you have H, then maybe let's have another one here, H, right, H, and then another H. So you can't say, no, I'll take this thing, right, and then I'm going to move this carbon there, right? You moved it, right? I actually moved this carbon this side. Now it's here, but it's still the same structure. Like, even if you ask a grade 1 learner to say, Munna, look at this one, and then look at this, and then you ask the learner, are they different? They will tell you those things are the same. So that means alkanes, they cannot have positional isomers, they cannot have functional isomers, they only have chain isomers. Okay, that is their structural isomers. They can only have different types of chains, meaning this one here, I can rewrite it okay, for this one actually it won't even have chain isomers, because literally the number of chains will still be the same. It can happen for maybe like maybe if you have 4 of them, but then you can have a chain isomer. Yes, ma'am? You have a question, or are we together? It can only be that this one, yes, it can have a chain isomer, but they can't have positional and functional. So I hope you do understand what are these functional isomers. We are saying the structures are different, but saying positional, chain, and functional is to specify that they are different in a way that they have different functional groups, or they have different chains, or they have different position of the functional group. Okay, I hope that is clear. Now, so for that one, you see, I go on and on. I'm not answering the question as keys. Compound D is butane. Oh, actually, I had written it. Hey, what now? Thank God. Thank God it's butane. So this is H here, H, and then H, right? And then another H, and then I told you that that other one cannot have even a chain isomer. So butane is the one that is going to work along with others, like, you know, pentane, heptane, and the likes. So this one can have a chain isomer, because now I can take this last carbon atom, remove it or detach it, and then put it here, replace it with the hydrogen. Take the hydrogen where? Take the hydrogen here, and then take this whole thing here. Then in that way, these things are going to have the same molecular formula, right? But then they are going to have different types of chains, because here in the longest chain you have 3, right? You have 3, and then in here you have 4 in the longest chain. So this would be the chain isomer, or the structural isomer. If I say structural isomer, I don't want to specify. They didn't really want us to specify, but you can see that when you specify, we call this a chain isomer. Now, they wanted its structure, which is what we did. They also wanted the IUPAC name. So yeah, this is the longest chain. It has 3 carbon atoms, and then when you number the carbon atoms, you will have 1, 2, 3. isn't it? So it means that you'll have something like this, and then when you name it, this will be 2 what do you have? You have a methyl, right? 2-methyl propane. Okay, 2-methyl propane, then you'll be okay, right? And then 2.2.3, is the isomer in question 2.2.2 a chain, positional, or functional? You see this thing of me talking too much. I already gave you the answer, right? So indeed, it is a chain isomer, okay? It is a chain isomer. So like I said, structural isomer is an umbrella term. Then when you say positional, functional, or chain, you are specifying what type of isomer it is. How are the structures different? All right. Okay, do we have any question there, guys? Was this understandable? Are we good?
Yes, sir. What is the mark allocation length?
Oh, yes. For the other one, I get it was 4, right? So they would give you 2 marks for drawing it, right? 2 marks for drawing it, and then 2 marks for the correct substituent and name. And here, yeah, and you get just a mark there. Then you would be okay. Okay, so let me see you guys on Friday. I think we are going to continue with is it maths, or yeah, I think it's going to be the what to call the solutions to triangles.